No. Y pues nada, nos vemos en el hackathon, nos vemos en el Super Happy Dev House. Se quedan con AJ.
Mejor. Entonces vamos a tener a AJ y también a Nathan, que nos van a estar apoyando con la parte de técnica, donde nos van a compartir pues algunos tips para poder desarrollar lo que quieran desarrollar este fin de semana, tomando ventaja de cosas que ya están hechas y de plataformas que les pueden apoyar. Entonces, AJ, all yours.
All right, perfect.
I just want to make like a little notation here, maybe. Cualquier cosa, ahora sí que lo que dijo David, pueden empezar a construir desde ahora. Si ustedes dicen, es que yo sé mover la red de Ethereum y me gustaría hacer algo en Ethereum, adelante. Este como tutorial va a ser más de Solana, pero estamos abiertos. O sea, mientras entre en todo este ecosistema de Web3, es bienvenido, ¿no? No hay una limitante de tecnologías ahí. Okay, AJ, are you there?
Yes.
Yeah, you can start.
Okay, perfect. Thank you.
No
Okay,
problem.
so high level, I just want to go over with you all, what you need to build your smart contract on Solana, the prerequisites, and just the flow of, writing your smart contract, building it out, testing it, and even deploying it on chain. So that's high level of what we're going to go over today. Okay, perfect. So the first thing we need is to install Rust. So if you were to go here, you can go ahead and run this in your terminal. And that will get started for the Rust download. And it might take some time. And that should be it there. One thing that it does mention is there is a Rust book that you could take a look at that will be useful for understanding some of the Rust concepts if you haven't dealt with Rust yet. So that would be right here, and kind of goes brief overview of the basics of data, functions, variables, and all of that. Okay, so yeah, first you'll install Rust, and then afterwards you're going to go ahead and install Solana. So here is the tool suite. So depending on whether you have Linux, Mac OS, or Windows, you're going to act accordingly. Really, you could go ahead and copy this, put it in your terminal, and that should be good right there. And it'll go through the process of installing Solana. Once you're done, go ahead and check the version, and that will tell you whether it was appropriately installed or not. The other piece to this is Yarn. So go ahead in here, you could install Core Pack or however you want to make sure you have Yarn installed. Very similar to the others, just pass that into your terminal and go through the instructions. Should be fairly straightforward, but if you guys have questions along the way, I'll be happy to help. So, all right, so I guess I'll start with what is Anchor. We're on the Anchor-Lang website. Anchor is a framework for building Solana smart contracts, and they have some really useful macros and functions and an SDK that removes a lot of the boilerplate in building out your first smart contract. So I highly recommend using it. And you can install Anchor by installing this tool called AVM. And what it is essentially it's Anchor version manager. And so if you went ahead and did AVM install, it would install Anchor for you. And then, AVM use latest, and then afterwards you can do an Anchor version and see what we have. Okay, perfect. So that's all good. That's really all you need to start your first smart contract. So let's go ahead and get started. So I'll go ahead and Anchor init workshop. And that's going to build out the boilerplate code and project for us to use. So I'll go ahead and enter in. Okay. One dependency we will want to add is TS Mocha. So go ahead and do that. And let's take a look at what we have inside. All right, so the first thing you'll notice is we have our, some tests. We also have the program, which is labeled workshop, and then source code. This is the entry point into the smart contract. And then here is our config file. So what this is saying here is, a few things first. We have our key for the smart contract, and then we tell Anchor what environment we want to point to. So this could be localnet, devnet, testnet, mainnet beta. But for now, we're just going to be developing locally on our computer. So we'll point to localnet. And then another thing is it's going to ask you what wallet you want to point to on your computer. And when you install Solana, there's some handy tools you can use to create your own wallet. So if you run Solana keygen new, that's going to install a basic wallet for you and put it in your config file, which the smart contract can reference. Okay, perfect. So let's go ahead. So that's the config, it's a TOML. And then next part is the test. So you'll notice this is in TypeScript. And then this portion is in Rust. So you're going to write your smart contract in Rust, and then you could use a TypeScript client to run some tests to validate your smart contract, which makes it really handy. Other than that, there's your basic TS config and, package JSON. You could look around and see what dependencies are there. And then, here's the config for the smart contract. And it's mostly boilerplate. We're referencing Anchor, and so it's going to be this version. So let's go ahead and get started with the actual smart contract. So you'll notice there's a few things here. This section called declare ID is going to be the public key of your program. And you can create your own wallet and reference your own key if you want, or you could use this one. I'm going to keep it as is, but when it actually compiles, it's going to reference this key unless I change it. And then the second part is going to be your actual program. This is where, the business logic is going to be, and right now we have an instruction called initialize. I like to think of it, if you have worked with, backend APIs, this is similar to, an endpoint. So once we deploy this on chain, if you call the instruction initialize, you'll be able to run code. And this is essentially what it does right now. So all it's doing is just returning an OK, and we'll update that. This last part here is the essentially it's explaining what the instruction can and can't do. And we'll dig into that more. But there's this concept of accounts with Solana. Now with Ethereum, if some of you are familiar, you could have business logic on the smart contract, and then you could also maintain state within the contract. Within Solana, if you want to persist any data, you have to persist it on to what's called an account. And I like to think of it as a mini database that's on chain. And so these people who are running, nodes, they have on their nodes accounts information for persisting state changes. So let's go ahead and get started. So what we're going to start with is, let's go ahead and with this instruction, I want to create a user that has to sign the transaction when it runs initialize. Now, what do I want to do? I want to store some data. So right now we'll start with something called a counter. And all this counter is going to do is increment a value by 1 when you run a transaction on it. Let's go ahead here. This is more boilerplate, but this is essentially, hey, I want to run the initialize instruction. And this system program is actually a Solana specific program that only it can do certain things. And so since we're initializing the account and allocating space, we'll need to call this and reference it. Because remember, this struct is saying, what can I do? What am I allowed to do when I run the initialize instruction on the contract? So yeah, let's go ahead and get started with specifying the actual account. So we'll create a struct called counter. And within that, we'll have one field called count, and it's going to have an integer type. And so if we were to go down here, we're going to include some macros to specify what we can and can't do. So if I were to specify here, I want to initialize. Here, I'll just put this down and then I'll explain. The payer, the user, and space. Okay, perfect. So I'll just start here. Okay, so what's going on here? All right, I'll fix this error, but what this is saying is when I run initialize, I'm referencing this struct. And this struct tells me what I can and can't do. And what I'm going to do is initialize and allocate some space on chain so that I can persist data. And the data I'm going to persist is, how many times have I called the contract and incremented this field? And so for here, I have, specifying initialize. I have to specify who's going to pay for it. Because remember, we're allocating space and the blockchain consists of, nodes around the world, essentially. And those are costing people money. And so we need to pay for that space that we use. And so when we're running this initialize instruction, we have to say who's going to pay for this when we initialize this account. So that's why I'm specifying this user right here. Now, what's this last part? Well, we have to tell Solana how much space we want to take up. With Anchor, there's always going to be 8 bytes initially, and that's going to specify it's basically like a flag, and it's an Anchor internal specification. But afterwards, we're going to say, okay, how much space do we need for this struct right here, this account? Well, if we're going to do 64 bits, that's going to be equal to 8 bytes. And so that's why I'm specifying hey, I want to specify the flag and then the amount of space I need to capture with this account data. If I were to add more to this, let's say, you know, other accounts, U64. Then I would need to either say 16 here, or, you know, you can do, you can separate it out and specify it that way as well. Now this is complaining. It's saying the payer specified for initialization must be mutable. And so that's asking for this macro here. Okay, perfect. And so high level, we have someone calling initialization. When you call this instruction, you need to sign it. And then the person signing it is going to pay for initializing this account called counter, which has some information that we're going to persist on chain. So let me go ahead and do that. Okay, perfect. So if I were to go to my terminal, say anchor build, it's going to compile the smart contract that we built so far. And, you know, depending on the hardware and everything, this could take longer or shorter. Okay, so now if I were to go back to our contract, if I go to test, this is where we could actually test the instruction that we just built. So right now, this is the boilerplate code that you're going to have. But, you know, as you change instructions and add to your smart contract, you know, you could add more to it. So all this is doing is saying, I have a program. One of the methods or instructions is called initialize, and I want to call it. And I should get some type of transaction result when I run this. So if I go here and run anchor test, perfect. So we printed out a transaction result, and we have a passing test. Now, a few things happened here. So we built our smart contract, and then when it's running the test, it's actually launching a local blockchain or validator, if you understand what that is. And so it's running a blockchain, and then it's calling the instruction and returning a signature. If we go back to our project, one of the really helpful things that I like is you could look at the actual log output of your smart contract. So if I go here, I could see that there was a transaction that was executed. And, you know, since the blockchain just started, you know, this was slot 3 when it ran. This is the signature. And what instruction did it call tied to this program? Well, it called the instruction initialize. And, you know, compute units is a way to say, you know, how much compute does your smart contract take up? There are capacity limits to how much you can do. But right now here, it took, you know, 7,580 out of 200,000. And it was successful. So let's go back to our core logic here and do a few things. So right now, all this is doing is allocating the space, and that's great and everything, but we want to actually add some business logic here. So if I were to create another instruction called, and just in case anyone's curious, this tool I'm using is called GitHub Copilot. It's really useful. It's not always correct, but it does try to guess, you know, what you're going to write based off open source code. So it's really handy. I'd recommend it, especially with learning this if you can. Okay, so we'll say add to, let's just say increment counter. In order for it to be an instruction, we need to wrap it in a context. And then really, it's just going to be a function. You know, we could do it this way, or if you wanted to, you could say reference the context. Okay, now that I have the context, I need to change or modify data that's in the accounts, which is data that's persisted to the chain. So I'll reference the accounts. And you know, what are some of the accounts here? Well, the only one we have right now is a counter account. So I can reference that. And then, you know, the actual field there. So what this would do is when I call this instruction, I would be able to add or modify the data tied to this account. It's very basic, but this covers a lot of concepts tied to, you know, the flow and building out your contract. So now this is unknown currently. So we need to tell the compiler essentially what this is going to be able to do. So I'll create a struct called increment counter. And we could, you know, make sure the user is signing the transaction. And that way, if someone tries to call it without signing it, it won't allow you. So I'll just go ahead and do that again. So signer. And then now, instead of all this code right here, the only thing we're wanting to do is actually mutate the state. So I have to tell it, you know, what we can and can't do. And if they call this instruction, since we are mutating and adding a value, I have to specify that here or else I'll get an error. So if I ran that, anchor build, and perfect. So that built out. And then if you wanted to write a test, you could add on to it. So let's say instead of is initialized, we want to increment counter. And so we're going to create a call and .methods .increment counter RPC. And then you can log it out. So, okay, perfect. And this would be, you know, how you could just add on to tests. So as you can see, there's a, you know, your instructions, there's describing what they can and can't do, and any data that you want to persist, you're also going to reference. And then you could continue along and do that, you know. If you, as you can imagine, if you wanted to, you know, you could start adding methods to the counter and say, you know, send transaction, send money, send Solana, and, you know, do some things there and build off. And instead of, you know, just modifying a field, you're going to start to call methods, you know, do something. And then it would run any logic you had here, essentially. And that's really the basic flow of, you know, starting out with development. Here, Let me go ahead and delete this. I'll make sure this builds. Okay, so we were able to write out some instructions. We were able to persist some data to state and tell Anchor what these instructions can do. The last thing I'd like to do is actually deploying this. So right now, we are referencing our local net, but how would we deploy this to actual servers around the world? Well, you could specify what cluster you want to deploy this out to. And so DevNet is basically a lot of validators or nodes running around the world that are provided so that, you know, blockchain developers can test their code, deploy it out, and verify some things. So let's go ahead and do that. Let's actually deploy this smart contract out and see what we get. Okay, so if I were to run, okay, so we were able to deploy this out. If I were to actually look on the Explorer, this is a website that allows you to look at some data of the blockchain. So I'm going to go to the environment. So we have different environments. Mainnet beta is, you know, real money moving around, real transactions. You have testnet, and then devnet is going to be, you know, your developer environment. And so if I were to look at this, I could go in and see that we just deployed this a few seconds ago. This is the transaction signature we got. And you could, you know, click around, become familiar with it. You see the timestamp, what slot this was deployed on. And then, you know, there's some things that happened here. This is, you know, DevNet Solana, but what it's saying is it was costing us some money to deploy this out. And then, yeah, you could see the system program. It created the account that we wanted to, and, you know, return success. And if we wanted to call out the program on DevNet now and not have any of this code locally on our computer, you'd be able to. So let me just move this up. So last part I just want to talk about is what happens when you actually build out your smart contract. It will generate what's called an IDL. And I'd recommend looking through some of this just to become familiar. But this is essentially a schema or spec that defines what our contract can do. So you'll see here under instructions, there's initialize. You know, what are the accounts associated? You have the user signing the transaction, the counter, you know, is it mutable? Can you sign it? Really all the metadata associated with the contract. And there are certain blockchain explorers where if you deploy this file out, it makes it more friendly to be able to look at the details of your contract on chain, which is really nice. So, okay, let me go back to the Anchor website. You know, I just did a very high-level overview of, you know, what you can do. We're able to go over deploying out the smart contract. There is a project called Tic-Tac-Toe, which I think would be very useful to go through. And it will talk through, you know, creating an account. If you have specific types that you want to build, make sure you could serialize and deserialize them. It covers a lot of concepts, but probably take a little longer than the time allocated. So this I would strongly recommend, if you could, before the hackathon, go through it and just kind of see what you can get out of it. There are a ton of tutorials online. I would search, Anchor tutorials. There are plenty open source. There's a lot of open source code you can look through. And we also have a reference in our hackathon paper that will show, some of those tutorials in open source code that you could dig through. So, all right, I want to make sure I leave enough time. I know that went over a lot of new concepts, and the goal of this is not necessarily that you understand everything about the smart contract and how to deploy it and everything, but to expose you to what you can and can't do, and then the basic flow of writing some code, testing it. Once you feel ready, you can deploy it out. So, yeah. Any questions?
Okay, I think it's everything clear.
Perfect. Yeah, like I said, we could link any of this information. Also happy to answer any questions afterwards in the Discord. Really happy to help where I can, but hopefully, this can at least get you comfortable with seeing what's possible out there that you could build. So, great.
Yeah, I think it's a great introduction because I know there's people that it's already trying to do things with Solana. So I think the tutorial is pretty great to just start clicking things. So thanks for the time. Yeah.
Disculpa, tengo una pregunta.
Adelante. There's a question.
Según lo que yo entiendo, el protocolo de Solana ofrece la opción para poder crear tu contrato dentro de esa misma red. Mi pregunta es que si al momento de crear tu contrato o tu proyecto, pues se le puede decir dentro de la red de Solana, es posible que esa misma red de Solana se conecte con, no sé, otra red, la de BNB, la de Ethereum o ADA, no sé. ¿Se puede o no?
De hecho, eso es lo que iba a decir.
Resumiendo, para traducirle a AJ, lo que dijiste fue que si cuando haces un contrato se podía como pasar a otras redes, ¿cierto?
Sí, que se pudiera conectar. Ajá.
Okay, so AJ, here Alejandro is asking that if you make a smart contract, if that smart contract can connect to another network.
For this specific thing I wrote out, this would be deploying to Solana specifically. So it wouldn't work in this case. But there are certain frameworks that try to make that possible. They're very new though. So I wouldn't, at least the ones that are, trying to deploy to Solana or Ethereum, for example, I wouldn't recommend it, probably because you'd run into a lot of config issues, if that makes sense. You're more than welcome to. Just know it might be harder than typical Solana or, Ethereum Solidity development, just because it is trying to satisfy two requirements. Does that make sense? So I guess the answer for this specific project, you wouldn't be able to now.
Okay, let's just hear Nathan the translation of your answer, and maybe he can add more things to the question.
Para contestarte, sí, o sea, sí puedes hacer eso, pero necesitas usar puentes que te hagan transacción de una red a otra. Muchas veces, como dice AJ, es muy difícil hacer esos puentes y necesitas usar frameworks que muchas veces traen esas vulnerabilidades que nos hacen perder. Incluso, no sé si viste la noticia de lo que pasó con Axie Infinity, por un
Sí.
puente entre la red de Ethereum y no me acuerdo qué otra red, tuvieron una vulnerabilidad y les estuvieron sacando dinero de ahí. Entonces, puedes usarlas y se pueden conectar, pero pues si no es muy recomendado hacerlo.
Ah, ok, muchas gracias.
Como que todavía está medio nueva esa parte, pero de nuevo, ahí hay un problema a resolver, ¿no? Podría ser algo para picarle, que sí es complejo, pero pues de nuevo creo que hasta que no entran a picarle es cuando te das cuenta de, ay, esto quizás todavía está muy primitivo y hay cosas que arreglar ahí. Ujú.
Ok, gracias.
No hay problema. Yeah, go ahead, AJ.
Yeah, great question. Any other questions?
¿Alguna otra pregunta? Okay, yeah, I think that we don't have more questions.
Perfect. All right, that's it from me then. Thank you very much.